This is a limiting reagent problem, and you're going to have a limiting reagent problem on your final. We're doing number 53. It says, in a reaction chamber, 3 moles of aluminum is mixed with 5.3 moles of chlorine, right? So 3 moles of this, and chlorine is 5.3 moles. Okay? So in a reaction chamber, I have 3 moles of aluminum plus, remember the IB people, that's a good equation to know, aluminum and chlorine. So in a reaction chamber, I have 3 moles of aluminum reacting with 5.3 moles of chlorine. Now, it says, the following balanced chemical equation describes the reaction. Here, yes?
There's a 2 in front of AL.
There's a 2 in front of AL. There's a 2 in front of AL. Excellent. Well done. Kaylee, the South Africans are the dark horse, and they just lurched ahead of the entire pack. Excellent. Well done. God bless South Africa and Nelson Mandela. Excellent. Okay, good. Now, so we have 2. There's a 2 there. Excellent. So 2 to 3. Excellent. Now, that's going to change things dramatically. Okay, good. Now, it says identify the limiting reagent. Identify the limiting reagent. All right? Well, you can do this in several different ways. You can do it simply by inspection, and if the excess reagent is significantly in excess, then it's obvious. Otherwise, you're going to have to do some figuring, some ciphering. You're going to have to do a little ciphering if the excess is low and it's near. So you're going to have to do a little ciphering. Okay. So, what is the relationship between aluminum and chlorine? It's going to be 2 to 3, right? Correct? Yes? If I use all of this, how much of this do I need? How much of this do I need? In other words, you can't see that, or right? So in other words, look, this is 50% greater than this, isn't it? This is 1 more. So what part of 2 is 1? 50%. So this is 50% more. So what's 50% of 3? 1.5. So you need 4.5 of this, right? Right? So do you have 4.5? So what's in excess and what's limiting?
0.8. Aluminum is limiting.
Aluminum is limiting and chlorine is in excess. Now, if you couldn't see that by inspection, you could simply do a calculation. And as long as you establish, you only have to do 1. If you find out one's limiting, then the other's excess, etc. So what you say is 2 aluminums over 3 chlorines equals 2 over 3 equals 3 over x. Correct?
Correct.
3 times 3 is 9, divided by 2 is 4.5. So you need 4.5 of this. Will?
Never mind. I answered my question.
Excellent. So, how much of chlorine is in excess?
It's 0.8.
0.8, correct. That's okay. All right, now, calculate the number of moles of product formed. The number of moles of product. Calculate the number of moles of product. Let me say that again. Calculate the number of moles of product. The number of moles of product. How would you do that? How would you do that? Yes.
Use the limiting reagent and then calculate using more ratios.
Yeah. Okay.
I have a question.
All right. Do we have the answer in the back of the book?
Yes.
Is anybody looking at the answer?
Yes.
Okay. All right. Yes, Will.
Would it be 7.5 mole?
Uh,
You have to conserve the mass, so right?
the question is this. Let me redo the question. Some people are not paying attention. Zayed. Okay. So it says, calculate the number of moles of product formed. The number of moles of product. What's the limiting reagent? Aluminum.
Aluminium.
And how many moles of aluminum are consumed?
3.
3, right?
Yes.
What's the relationship between aluminum and aluminum chloride? 2 to 2 or 1 to 1, right?
Proportion over and over.
All right, there's the Canadian team with the use of proportional relationships. They are rabbit hunting again. Okay, that's fine. They're going to eat well. Okay, Canejo, right? Canejo? All right, one of the Canadian teams speaks Spanish. Okay, how do you say rabbit or hare rabbit in Arabic? What is it? Okay. Zaid, could you try to remember that a Westerner and Arabic is like the hardest language to pronounce in the entire world to me? Could you say that slowly? Say it again. Why don't you come up here and stand right here and say, we're going to take a 10-second universal language break and say rabbit in Arabic. You got to do it loud though, okay? Okay? All right, say loud. Go ahead.
أرنب.
Arnab.
Yes.
Is that right?
Yep.
Arnab. Did I do that right? Arnab. I like that. I like that. It sounds like the sound I make after I eat the rabbit. Okay. Arnab. Okay. Excuse me. Arnab. Arnab. Is that right? I like that. Right, I'm going to go home and they're going to say, so tell us the Arabic you learned in 2 years in the United Arab Emirates. And I'll say, Arnab. And I'll say, what's that? And I'll say, I know how to say rabbit in Arabic. Oh, there are a lot of rabbits in the Arabian Peninsula? And I'll say, I have no idea. Okay, good. Are there rabbits here? Are there? Yeah? Okay. Arnab. I like that. Arnab. Okay, I'm going to say that all day. You're going to see me later. I'm going to say, Arnab. Okay. So, the relationship is 1 to 1, isn't it? So how many moles of product am I going to produce? 3 moles, right? Okay, we don't even need the color coordinator for math calculations for that, right? Okay, we've silenced the color coordinator for math calculations, exactly. Look at him, he's like, he's stunned, okay? So if I have 3 moles of this, I have 3 moles. It doesn't matter how many moles of this I have, okay? It doesn't matter. Yes, okay, fine, I'm using 7.5 moles of reactant to produce 3 moles of this. Well, that's just the way it is. The number of moles in a chemical reaction is not conserved. You're confusing that with conservation of mass. Yes? Conservation of mass. It's not conservation of moles. All right? It says calculate the number of moles of excess reagent remaining after the reaction. Didn't we already do this?
Yes.
What's the answer? Canadian team, go for the gold.
0.8.
0.8. We kind of already did that, didn't we?
Yes.
0.8. Yes?
Yes.
Now, think back. I was soundly criticized the other day. Not even a week ago, Mr. Darcy was soundly criticized for not spending enough time on stoichiometry. Soundly criticized by someone in this room whose name shall remain unspoken. I will simply refer to that person as Voldemort, okay? So, let me ask Voldemort. Voldemort, is this pretty basic stuff now that you're in acid-base chemistry? Thank you very much. Why did I say that, to be fair? Oh, to be fair to yourself, not to me. God forbid you're being fair to me.
At the time.
Excuse me?
It was mostly the other students in the room at the time. I was just there backing her up.
Okay, all right. So you were being a lawyer, not a chemistry student. Oh, how silly of me. The point is this. This is the point. Yes? My camera's what? Okay, I'll fix it, but thank you. The point is this, ladies and gentlemen. This is the point. The point is this. That stoichiometry is so central to everything we do in here that I'm not going to even suggest you can learn stoichiometry in the 2 weeks that I assigned to learn stoichiometry. It takes months to really be comfortable in stoichiometry, and I knew that was going to happen. Do you understand? Understood? So this is a perfect example of why I work backwards in the review for this test. I started with acid bases and I worked backwards to stoichiometry because I know that you're going to be most comfortable with stoichiometry. Everything we did to this point is essentially based on stoichiometry. True or false? There are problems in chapter 19 in acids and bases that are stoichiometric. Same thing with solutions. Clear? Are we done? Yeah. That was number, what? 53. Okay, we're done. We're out of here. Okay.